right, taking a look at our discussion topic today, vectors in the plane. These are two-dimensional vectors. Consider them to be flat. An introduction to vectors and their three representations. Now we're not going to cover all three representations in this section. We're going to review one real quick. We know the definition of a vector. Vector is a quantity that has magnitude and direction. The first direction is an arrow. We talked about that in the previous video. The book is not going to call them arrows. They're going to call them directed line segments. Please don't let that confuse you. The magnitude is simply how long the arrow is. The direction depends on where it's pointing. Which direction we are pointing. The initial point is the tail, and the terminal point is the head. That's a quick review from the last video. The second representation we're going to talk about today is something we're going to call component form. Now, please don't get confused because this looks very similar to an ordered pair. The difference is we're going to put an arrow above it so we understand that this is a vector, that we're moving this way. Okay? The horizontal component is our x component. That tells us how much we move in the horizontal direction. And the vertical component is comparable to our y component. It tells us how much up or down we are. In standard position, if I have a vector, for example, that says go to the right 3 and up 5, standard position tells us that we need to start at 0, 0. So the tail will go to the origin. Okay? And from there, the head of that vector ends up at the point 3, 5. Okay? So this is the tail. This is the head. Notice, this 3, 5 is describing the vector, not the point. I can take this vector and I can move it. Okay? I can take the same vector and I can have a new tail. I can have a new initial position. Let's say I started it at 3, 8. Then I move my 3, 5, and my head ends up at 6, 13. Should be fairly obvious. I take 3, 8, add the 3, 5, and I end up at 6, 13. Very nice. Okay? Standard position starts at the origin, but we can move this vector anywhere we want on the plane. The zero vector is kind of silly. We set it up so we understand that the zero vector is the vector that's not moving anywhere. It's just 0, 0. Okay? Now, the magnitude, how long is my vector? Well, I have the vector 3, 5, and I think about it for a minute. This isn't that hard to figure out. We went over 3, and we went up 5. So how could I possibly figure out how long that vector is? Well, looks like the Pythagorean theorem to me. 3 squared plus 5 squared is the square root of 34. So the magnitude of any vector in component form is simply going to be the square root of x squared plus y squared. Okay? Now, it's kind of a funny notational thing that might take you a little bit to get used to. We are going to designate the magnitude of the vector 3, 5 by putting the absolute value sign around our vector. Okay? Basically, the absolute value is asking for how long the vector is. Actually, it's asking how far away from 0 do we end up if we move 3, 5. All right, here's some sample questions for you that we might ask about vectors in component form. And I'll give you a couple minutes to answer some of these, and then you can type the answer in if you're watching the Zaption version of this, and it will tell you if you got them correct. All right, thanks for watching.